This video covers section 5.7, which is probability with combinations and permutations. So the big idea of finding the probability with compound events is that you want to ask yourself the question, does the order matter of the items that you're trying to find the probability using? So if the answer is yes, you want to use permutation. So the answer would be yes in things like passwords, combinations, when you're earning an award like first, second, third place, when you're assigning someone a job or giving them a title. And then if the answer is no, you would use combinations. This is when you're like playing a card game and your whole hand, you can shuffle around and put it in any order you want, so the order doesn't matter. Same thing with like if I'm picking a group of people to do something, then it doesn't matter who I picked first or who I picked last. They're all just one group in the end. And so in that case, I would use combinations. The formula is essentially that we're going to use to find probabilities is that the probability is the ratio of the number of ways to obtain a given outcome to find the numerator. And then the denominator is always just going to be one value that is all possible outcomes, kind of ignoring the more specific pieces of the problem. So in the first example, we have a landscaper who selecting 2 trees to plant. So he's just planting 2 trees. So if I'm planting 2 trees, it's not saying one closest to the street and one further from the street. That means that order doesn't matter. So we're going to use a combination. He has 5 to choose from. So this is the total number of trees that he has. And he's selecting 2 trees to plant. So that means that if I'm thinking about the number of possible outcomes, he has 5 trees to choose from. He's choosing 2 trees. So my denominator is going to be 5C2, which if I calculate that is a value of 10. So 3 of the 5 trees are deciduous and then 2 are evergreen. Okay, so I've got 3 and 2. What is the probability that he chooses trees of 2 different types? So he wants one of each. I'm just going to go in the order that they were given. Remember that the order doesn't matter, so I could do the opposite of what I'm going to write down. Okay, so he's got, if I want one of them to be of each type, the first type, we have 3 of them. I want one of those 3 to be chosen. And then I want one of the 2 other type to be chosen. Okay, so when I'm choosing, I'm multiplying. So it works like an and probability, right? So I'm multiplying. I choose 1 deciduous tree and then I choose 1 evergreen tree. There are 3 total deciduous, 2 total evergreen. I'm choosing 1 of each. So I could write that as 2C1 times 3C1. It would still be the same answer. So if I calculate these values, the first one is 3, and then the second one is 2. So if I do 3 and then the NCR button 1, I get 3. And if I do 2 and then the NCR button 1, I get 2. Okay, so that means that I get 6 out of 10, which is 0.6. It wants us to write it as a percent, so that's 60%. Know that in some of the problems, it's just going to have that as the answer choice. And so it's just plugging in the formula. So be sure to look at your answer choices before you start calculating things, because some of them are really just plugging in. And again, multiplication's commutative, order doesn't matter in multiplication, so it could be switched there, and that's still the same answer. The other example we're going to do, we have 6 girls and 4 boys that have entered in the science fair. So if I have 6 girls and 4 boys, that means that there are 10 students total in the science fair. They are awarding first, second, and third place. So if I'm putting them in order, then order matters. So that means that instead of using NCR, we're going to use NPR for this problem. So what is the probability that a girl wins first place award while boys will receive the second and third place awards? So let's find the total number of possible outcomes first. So we're going to use a permutation. There are 10 students total. And if I didn't care who got first, second, or third, there's 3 different places that I'm filling. So I'm going to choose 3 people out of the 10. So that's going to give me my entire sample space, or the number of my sample space, which is 720. So there's 720 different ways that those 6 girls and 4 boys could get first, second, and third place. Then I have to look at the scenario that I want. So I want it to be girl wins first, boy wins second, and then boy wins third. So I can group the boys together and think about how many places they're filling. So if I think about the girl first, so in order for a girl to win first place, I have 6 girls. I only want one of them to win, and they're going to win that first place. So 6P1 is going to be the number of different ways a girl can win first place. Then I've got 4 boys, and I want them to fill 2 different places, so second and third. So I want 2 boys to be chosen where order matters. Okay, so that means that 6P1 times 4P2, all divided by 10P3, will give us the probability that a girl wins first place and 2 boys win second and third. So again, remember that this could be what the answer choice looks like depending on which problem you're working on. So we calculate these other 2 values. 6P1 is 6, and then 4P2 is 12. So there's 12 different ways that those 2 boys out of the 4 can win second and third place. So if we multiply that, we get 72 over 720, which is a 10th. So that means that it's 10%. There's a 10% chance that that will happen. Okay, so again, look at your options to tell if it's just having you plug into the NPR and NCR formulas, or if it's actually having you calculate something. So when order matters, we're using a permutation. So in this case with first, second, and third place. We're using a combination when order doesn't matter. So when I'm just placing things in a group, then I'm going to use the combination. Either way, I'm doing the probability, I'm using the permutation or combinations, a product to find the number of ways to obtain a given outcome, and then a more generic one with the 2 biggest numbers to find the number of all possible outcomes.